Alright, so welcome everyone. In this lesson, we're going to discuss about the important density and the velocity section, which is again really going to be very important stuff. So far we have discussed about the important dynamic simulations attributes, the important fluid emitter attributes, which are really very important to understand the motion of the dry ice. But now here we would like to go for the content details, which is the density sections. I must have to say that if you can get the perfect idea of this lesson particularly, I can say that you have mastered the entire course. Okay, so what I want to tell you here is that the density is now playing a role of, you can say, material property. You may could say as a surface property, which is showing us the visibility. No doubt it has to play a role. The opacity graph is also responsible for that, but here density is going to be represented as the material property. Okay, so followed by the density scale, we like to go for zero point 0.5, which is the default value. I guess idle for the good start. Now for the buoyancy, the positive values of the buoyancy will take the reaction to the upwards. It's like a upward force. Okay, but by watching the behavior, the reaction of the dry ice, since it's really going to be cold, so it will try to reach to the downward side. So we like to have a negative buoyancy for that. So what I like to go for here is that for the buoyancy section, I want to go for -8 as the start, which is, I guess, a good point, of start. Okay, now as a reaction will start producing, we also want that thing to be get finished with the reasons of the time. Okay, it shouldn't be like that. The dry ice should keep on sustaining itself. So for that, we'll like to go for the dissipation. We'll like to have a fairly low values of the dissipation, because I also want my fluids to get pop outs, because I'm going to show you up, of course, those important play blasts in the timelines, where you're going to see that whenever we're going to play the timeline, the fluid will start getting accumulated near the surface of the emitter. The time it just takes to come out of the bowl, it will get diminished, or you can say dissipates in the middle of the path, which is fairly, I don't want that. So that's for the reason I would like to keep some low values of the dissipation. So I guess 0.25 should be a good start. Okay, and now I would like to go for the density pressure, and let's just skip the diffusion because I just don't want to have the diffusion for this particular reaction. Okay, for the density pressure, this is really going to be a very important stuff, guys. So I want to have you to pay attention towards the density pressure in conjunction to the density pressure thresholds. Okay, what exactly the density pressure is, that I think you all may could figure it out. What exactly is the pressure? It is basically the outburst, or you could say the expand of the energy, which will try to repel or expand the forces, and it's going to play the exact role as the name suggests. In this case, like to go for the density pressure with 1. Now this attribute is really going to be you can say the soul of the reaction, the soul of the dry ice, and the density pressure will going to work in conjunction with the forward advection also, because the more fluid get pressurizes, this important attribute, which is the forward advection, will try to push them further outside the ball. All right, so this is very important. So these particular attributes like the density pressure threshold, the forward advection, the high detail solve, and the gradient force, I must have to say that they're not working simply in the straightforward, but they are in synergy to each other. Okay, so again, coming back to the density pressure threshold. Now density pressure is quite okay. What exactly is the threshold? See, threshold is basically the minimum amount of value which is required to sustain or to get start with the reaction. So in this case, you may could consider that if I would like to go for 2.5 as a value for the density voxels, what exactly it is means is that the fluid requires the voxel values of 2.5, which is the minimum value to get start. Sooner or later, it will get the values of 2.5 inside the density voxels. It will going to release the pressure of 1, which is something like this. So those voxels that have crossed this particular threshold will try to pressurize the fluids. Alright, I think so you must have now got my point. Okay, now coming back to the noise, well, I don't think so we're really going to need this attribute a lot because the dry ice is simply a very smooth in the reaction. But still, I just want to have some little bit subtlety or the variations inside the density. I like to break the normal flow of the fluid. So again, 0.25 to maybe 0.5 should be an ideal start. Let's say you can have 0.5 also, it's not a problem. Okay, fine, that's okay. Now again, the density tension and the tension force, we don't want to use these two things because I have already utilized the viscosity, so that is also already taking care of the stretchiness inside the dry ice smoke behavior. Okay, now for the last section of the density, the gradient force. The gradient force is really going to be very helpful for us. Reason why? Because it will try to push the fluids again outwards, or you may could say regarding the direction of the moving fluids. But again, a word of precaution. The gradient force, if used with high amount of values, will try to break your you may could say your reaction unstable. So the gradient force should be somewhere around, I guess 12 is a good start for that. Okay, now we are done with the density sections. Now I'd like to come for the velocity. In the case of the velocity, the swirl is really going to be important because I have noticed that the beautiful swirling, vorticity and the blowing of the smoke is just because of the swirl. The moment the fluid gets pop out of the surface of this ball, it will try to show the a little amount of the vorticity or the swirl inside the behavior. So I think so a value of 8 or maybe 10 should be a good start for that. And again, just be careful guys, while using the high amount of the velocity swirl, and again with high detail solve to all the grids can give you some little bit of the artifacts, because here in the case forward advection, it is not dealing with the velocity. Okay, so you have to be very careful regarding that. Just do not push this value to something more beyond the 10. Okay, and for the noise, I just want to have that thing to 0. I do not want to consider that up. Okay, so I guess with the completion of the density and the velocity, we have completed the attributes of the dynamic simulations, the attributes, the density and the velocity. Now I guess we are good to start with the opacity graph, the shading, the color, the look and feel of the fluids. So we're going to do that thing in the next lessons. Okay.